Let's look at 4 examples that really confuse students, the common mistakes, and as Admiral Akbar here would say, it's a trap. The first trap is the common denominator trap. So the common denominator trap, a lot of people, they if you have a common denominator, there are special rules that apply to it. It doesn't apply to multiplication. I'll give you an example. 2/5 times 1/5. It's a trap. It's a big old trap. The trap is to look at the common denominator here and think, okay, well, 2, it's top times top, 2 times 1 is 2, and there's common denominator 5. Right? Wrong. The common denominator is irrelevant. Is that how you spell irrelevant? Okay. If we wanted to do this properly, it's still going to be top times top, bottom times bottom. 2/5 times 1/5. We did the top right, 2 times 1 is 2. But we have to multiply the bottom, even if they're the same number. 5 times 5, 5 squared, is 25. Does it simplify anymore? No, it doesn't. 2 is a prime number, 25 is an odd number, so that's as simple as it gets. And if you did that, you'd be right. Okay, main trick, if there's, just because of the common denominator doesn't mean that the common denominator carries through to the answer. Next little trap that a lot of students fall for is the 1 problem. I don't know what else to call it. Let's have a look at 2/7 times 141 over 141. And the first temptation for that is to think, oh no, so it's going to be 2 times 141 over 7 times 141. Ugh, what do I do there? I don't know much about 141 times tables. But notice our rule. Remember our rule. Any number divided by itself, as long as it's not 0, is 1. So 2/7 times 141 over 141 is the same thing as 2/7 times 1. And hopefully you don't need a calculator for that. It's 2/7. We're going to get to cancelling later on. Just a spoiler, if we wanted to do it this way, we could just cancel those 141s and be left with 2/7. That's quite a nice colour. 2/7, same answer. Okay. Let's look at a variation of that. It's a little bit more advanced. Let's do 3/7. Let's do 131/7, which is fine. It's just an improper fraction, over 4 over 131. Ooh. If you need to take a pause there and try to work it out, you could 131 times 4 over 7 times 131. Grr. Is that going to work? Well, there is a shortcut here. 131 over 131 is 1. So those are they're going to cancel. They're not going to cancel to 0. They're going to cancel to 1. Because 131 over 131 is 1. Any number divided by itself, as long as it's not 0, is 1. So our answer here, even though I like that colour, is going to be 4 over 7. Let's do it on the calculator just to prove that that's the case. All clear. So 131 over 7, and that's fine if the numerator is greater than the denominator. It's strictly a bit of a mistake, but that's fine in our case. For 4 over 131, 4 over 7. Like magic. The decimal equivalent is a nasty number. 4 over 7, the 131s cancel. The next trap, it's not really a trap, is if we have a number like this, 3 over 13 times 0 over 6,121,503. And you could be thinking, oh no, what do I do here? 3 times 1. Really? Do we really want to do that? No, because we know that any number, 0 divided by any number, as long as it's not 0, equals 0. Okay? So 3 over 13 times essentially 0 to be precise is 0. Any number times 0 is 0. In this case including 0. So just be careful. It's not really a trap, it's kind of a shortcut. Another little trap that trips students up is when the numerator and the denominator are sort of not nice over not nice. And what do I mean by that? Well, let's say we have 3.14 over 7 times 28.3 over 62. You could be thinking, oh no, I don't know my pi to 2 decimal places times table. I certainly don't know what 28.3. In this case, you would just use the calculator, to be honest. But it's exactly the same. It's upstairs times upstairs over downstairs times downstairs. So we're going to have 3.14 times 28.3 over 7 times 62. I have no idea what that is. Thankfully, here's one that we prepared earlier. So I'm going to put it in brackets in this case. 0.14 times 28.3 close brackets over 7 times 62 xe, and it's not a nice number. It doesn't go into a whole number. There is no decimal fraction in this case that it goes nicely to, but we can kind of convert it into a proper fraction. 3.14 times 28.3 is apparently 88.861. 862, even better, over 7 times 62, and I have no idea what that one is either. 434. So our answer is 88.862 over 434. Just kind of got a bit of a divider there. Okay, it's no problem at all if we have a decimal fraction inside our proper fraction. That's fine.